Alright, let's continue. With multiplication and division in scientific notation, is quite simple. So it's very simple with multiplication and division. You just have to multiply or divide the coefficient and then add or subtract the exponents. So remember, recall the formula that I just gave you about these base and exponents. So if you have same base a raised to the power of m multiplied by the same base a raised to the power of n, then you have a raised to the power of m plus n. Okay, and similar, you have a raised to the power of m divided by a raised to the power of n. Then you would have a raised to the power of m minus n. Okay, so with this one, let's take a look at this example. You would have 3 is a coefficient, 2 is a coefficient. So what happens is that you group and you multiply the coefficients together. So 3 times 2, and then you multiply, and they add the exponents. So here you have 10 raised to the power of 4 plus 2 equal to 6 times 10 to the 6th power. Okay, so using this formula. Now the same thing with this again. You have 2.1 times 10 to the 3rd power multiplied by 4.0 times 10 to the negative 7th. So you multiply all the coefficients together and then you add the exponents. So what it means is that you multiply by 10 raised to the power of 3 plus negative 7. So you would have 8.4 times 10 to the negative 4. Now the same thing with division, because you guys, I just have to divide the coefficient. So in this case, I would have coefficient is 3 and 6. So I would have 3.0 divided by 6.0, and that is my coefficient. Now what happened is that I also multiply. Remember, this is a multiplication, what you have here. So what happens is that you have 10 raised to the power, and remember here you subtract the exponent in the denominator from the exponent in the numerator. So you would have 5 minus 2. So in this case I would have 3 divided by 6, 0.5 multiplied by 10 raised to the power of 3. Now this is not a correct scientific notation yet, because what happened is that this is this one, my coefficient here is smaller than 1. So what happened? Now if I want to make it greater than 1, so this one I have to multiply 0.5 by 10. Okay, and because I multiply this by 10, I have to divide this by 10. So here I have my final answer is 5 times 10 to the second. Okay, because 3 minus 1 second here. Now addition and subtraction is a little bit more complicated, but it's not that big of a deal. Now the exponent, the key here is that your exponent must be the same, and once you have the same exponent, then you just have to add or subtract the number. So for example, in this case I have 10 to the 3rd power, and then this one 10 to the 2nd power. Now you have several ways of doing this. The key idea is just you want to make sure that this one they have the same exponent. Now let's say that I want to make this as the exponent from 2 and make it 3. So I would keep this number the same. So let's say that if you want to make it 3, so that means what? That means you multiply this by 10, right? Yeah. and if you multiply this by 10, then you have to divide 8 by 10 as well. So in this case, your new operation would be, excuse me for my handwriting, because I have a problem with my right pad. So 5.4 times 10 to the third power, and here in this case plus again 8 divided by 10, which is 0.8, 0.8 multiplied by 10 to the third power. Okay, so what happened is that, again, because now you just have to add up, subtract the number. So in this case you have 5.4 plus 0.8, and then you have the common factor here, right? The common factor is times 10 to the third power. Okay, so 5.4 plus 0.8 is 6.2 times 10 to the third power. So here again you will see that this one, let's check, 6.2 smaller than 10 greater than 1, and then we have this. Okay, so this number makes sense. Now it's your turn. Let's pause the video and try these questions. Okay, so here's a solution. What happened is that you always have to write in the your answer in the correct scientific notation. Now what happened is that you go, because it's a multiplication, then you just have to group the coefficient together. So you group 8. So you group 8.0 and 7 together. And then you would multiply by 10. Okay, now what happened is that you're going to add the exponents, so -2 plus -5. Okay, so what happened is that you have 8 times 7, 56, multiplied by 10 to the -7. Now remember, this is not a correct scientific notation, so what happened is that you divide this by 10, right? And we divide by 10, then you have to multiply this by 10 as well. So here you would have 5.6 times 10 to the -6. Okay, alright. So with this one, it's the same. Now it all depends on you. If you want to make this a -3, or if you want to make this -2, it doesn't matter. So let's say that I want to make this a -2. Now what happened is that if you make this -2, then you have to multiply this by 10, and then you have to divide 5 by 10. Okay, so your new operation would be 7.1 times 10 to the -2 plus 0.5 times 10 to the -2. Okay, -seconds, and then you would have 7.6 times 10 to the -2. Okay, now we move on to the next discussion, which is accuracy and precision. Now with a scientific research, you would produce a lot of data, or you would do a lot of measurements. Now the ideal situation is that your measurement should be both correct and reproducible. What it means is that if you want to weigh, let's say 2.0, like exactly 2 grams of matter, and every single measurement, like every single time you measure 2 grams of, let's say, table salt, your you have to get exactly, you should get exactly 2 grams, and then every single time that you measure 2 grams of table salt, you have to, you should be able to do that, always get the 2.0 grams of table salt. Now, that is the ideal situation. In reality, it doesn't happen that way. Okay, so for example, if you do research, you will see that one day, one very lucky day, you would make a very good, you would produce a very good result, very good data. Now what happened is the next day you want to reproduce it, your data is just like go out of whack. So what happened is that in real life situations, we don't really have that, we are not that lucky. So precision is what? Now precision is a measure of how close a series of measurements are to one another. And so for example, if you do a measurement, 5 measurements, we want to know how close are those 5 measurements. Okay, irrespective of the actual value. Now, so for example, if you intended to measure out 2 grams of table salt for 5 times, right? And let's just say that for 5 times altogether, you measure about, or you always measure like 2.3, 2.2, 2.3, 2.3, 2.2. It's way, it's over 2 grams, right? It's over 2 grams. But the 5 times that you make the measurement is always about 2.2 or 2.3. So you are precise in that measurement. Now accuracy is different. Accuracy actually cares about the true value. So let's say that you want to measure 2 grams of table salt. Those are 2 grams that is. If you measure out of 2 grams, then your measurement is accurate. Okay, so this little picture here is actually very useful for you in illustrating the relationship between accuracy and precision. Now, for example, if this is your goal, okay, a true value here as the middle here. So what happens is that if you see these black dots here, so it's all over the places. So we would conclude that this is the low accuracy and low precision. Now what happens if you move on to this one? You see that all the dots there, all the shot here are actually way further away from the true value, which is the intended shot. However, they are close together, okay, very close together. So we would say that this is low accuracy. Of course, your goal is here, the true value is here, but then so low accuracy but high precision, because they have the measurements here, the shots here are very close to one another. Now let's take a look at this one. So you have 2, 3. So you see in this one you will see that you have more shots that shot at the intended goal, so which is the true value. So we would say that this is high accuracy. But see, like you make what 7 shots, but then shots here are far away from each other. So what it means, it is low precision. For this one, however, you see that all 7 shots, occur right in the center. So we would say this is high accuracy and high precision.